Hello grade 9s and welcome to Unit 2. Congratulations on making it through Unit 1, which I have always considered probably the most difficult unit in Math 9, but we start out with it because we're going to use squares and area many times in the course, so it's important to get that out of the way first. So for Unit 2, let's just head right in. 2.1, what is a power? When an integer can be written as a product, and I'm just going to put in here product with a little dot for multiplication, right? We're always dealing with multiplication when we're dealing with powers. Okay, so here's another important term here. Equal factors. When an integer can be written as a product of equal factors, we can write the integer as a power. Okay. So for example, 5 times 5 times 5 is 5 to the power of 3. All right. Now, just to make sure that you understand what these are, an integer never has a decimal. It'll just be a number like 1 or 2 or -3 or something like that. It'll never have decimals. Equal factors. Okay, when we deal with factors, factors are just the numbers you multiply to get to the product. So this 4 here would be the product, and then both 2 and 2 are factors, and in this case they're equal factors. They're the same number, right? So if we look over here and we look at the 5 to the power of 3, the base number is the number to which the power is applied. So in this case it would be 5. The 3 is the exponent, and 5 to the power of 3 is the power. Now that kind of looks like 6, so I'm just going to redraw it, make sure it looks like a 5. So 5 to the power of 3 is a power. So that's just illustrated over here, right? The base is the 5, the exponent is the 3, and the whole thing is the power. And we usually say for this, when we say it's, we say it's 5 to the third, or 5 to the power of 3, or 5 cubed. So 5 to the power of 3 is a power of 5. A power with an integer base and an exponent of 2 is a square. So if you see, and our entire first chapter dealt with squares and estimating square roots and things like that. So anything to the power of 2 is a square. For instance, 3 to the power of 2 would be considered a square. Let's look at the number 25. Okay, there's 3 ways to write 25. In standard form, basically it's just the number repeated, so that's 25. How are we going to get 25 by multiplying the same number by itself, the same factor? Well, that would be 5 times 5, all right? But if we're going to write that as a power, then we would have to write that as 5 to the power of 2, or 5 squared. So we always think of it, again, when I deal with squares, just think of a square. Draw yourself a picture. And we know that the square root of the area, which in this case is 25, the square root is going to be each side. So 25, the square root of 25 is 5, and a square, the sides are all the same, so obviously if you get one side, you got all the sides. A power with an integer base and an exponent 3 is what we call a cube. Okay? So for instance, 3 to the power of 3 would be considered 3 cubed. In this case, let's use a number called 125 instead of 25. In standard form, again, it's just the number. Okay? But as repeated multiplication, and remember, we have to use the same number for repeated multiplication if we're going to be dealing with powers. So in this case, that's actually just 5 times 5 times 5. So the same number multiplied 3 times. Well, if you have to multiply it, and there's 3 of them there, then you have to write that as a power, 5 to the power of 3. Now we're dealing with a 3-dimensional object, which we know is a cube. Okay, so if we, if we were going to figure out all the surface area of the cube here, it says 5 times 5 times 5. Actually, that'd be the volume. So if you were to count up all of the cubes, or all of these little tiny cubes in here, you would get 125. So let's do a couple examples here. Write as a power. Well, it's quite easy to write as a power because the base is always given to you. So there it is. It's 3. Now we just got to figure out what the power, what the exponent's going to be. So there's 1, 2, 3, 4, 5, 6 of them. So we're going to write 3 to the power of 6. All right. Now how do we write powers when it's just one number? Okay. Whenever it's just one number, it's always to the power of 1. All right. So that one's nice and easy. A couple more examples here. It says write as repeated multiplication and in standard form. Well, if we're going to write 3 to the power of 5 in multiplication form, it would just be 3 times 3 times 3 times 3 times 3. There's 5 of them there, right? And in order to write this as a power, it's probably easier just to, or as a standard form and find out what the answer is, it's probably easier to just use your calculator. So you should be able to find a power button on your calculator. But if you can't, you can just do it on your calculator as many times as you need to. So for instance, for this one, I'm just going to go 3 times 3 times 3 times 3 times 3. I think that's 5 of them there. 1, 2, 3, 4, 5. And the answer is 243. So writing this in standard form would be 243. Okay, so I'll just write that as this is the mult part, and this is the standard form part. Okay? 7 to the power of 3, exact same process, right? 7 times 7 times 7, because there's 3 of them. Well, we know 7 squared is 49, but 7 times 7 times 7 is 343. 343. So once again, this is the multiplication part, and this would be the standard form. And if you want to be really detailed, you would write this is the power. Okay, those are the 3 typical forms you'll see numbers in. Now, we need to recognize that Bedmass still applies to all the mathematics we do, forever and always. So I'm just going to do a little Bedmass reminder here. You may have seen this written as PEMDAS before, but it means the same thing. So B is brackets or parentheses. Okay, so that's the first thing you always do. E is exponents, and that's important because those are powers. It's just a different name for it. Division and multiplication, you just do in the order in which they appear. So those are next. And then same thing for addition, subtraction, okay? Just in the order that you see them. So from front to back, you got to do the brackets first, exponents, division, multiplication, and then addition, subtraction last. Keeping this in mind, let's look at the first couple numbers here, the first couple questions. So what we've got is negative 3 to the power of 4. Now, there's brackets on this question, which is really important because you need to know that the power always applies to whatever's in brackets if the power is touching a bracket. In this case, the power is touching the bracket, so whatever's inside the bracket is what we need to write as the power. So in this case, it's really like, not negative 4, negative 3. It's really negative 3, okay, negative 3, and then multiplied 4 times. Oh, God, I did it again. There we go, negative 3, negative 3, negative 3. So that's what this really means. You got to repeat that 4 times, but you got to make sure that you include what's inside the brackets. All right, so we know that negative 3 times negative 3, okay, this is going to be 9, okay? And then negative 3 times negative 3 here is also going to be 9. Sorry, positive 9, not negative 9. And then we've just got 9 times 9 is 81. Okay, so it's very important that you look at where the brackets go on this. This one's a little bit different. You notice it's still negative 3, but there's no brackets, and the 4 is just touching the 3. So what that means is there's a negative out front, and then on the inside, because the 4 is only touching the 3, it's not touching a bracket, it's just 3 times 3 times 3. Because the 4 is just touching the 3, it's not touching the negative sign. If it was touching the bracket like it was in the first one, then we'd have to put negative 3 in here. Well, the answer's still the same, right? It's 3 times 3 is going to be 9, times 3 is 27, times 3 is 9. So this is going to be, inside the brackets, this is going to be 81. Sorry, 81. But because there's still a negative sign out there, the final answer is actually negative 81. So that just shows the difference between applying a power to something that's inside a bracket and applying a power to a number outside of a bracket. Now let's look at this one, okay? So we've got a negative outside, whatever it is, and then I'll actually even put the negative in brackets and call it negative 1, because the negative is really just negative 1. Then what we've got here is we've got the negative 3 inside brackets. The 4, the power, is just touching the bracket, so we have to multiply whatever is inside the bracket 4 times. So in this case, it looks a little bit like the first one we did, where it's all these negative 3's multiplied together. Negative 3. Well, we know that when we multiplied all these negative 3's together, okay, we know that this equaled 81. But we also know that there's a negative 1 on the outside that we haven't touched yet. So negative 1 times 81 is negative 81. So it's very important to look at what the exponent is touching. And if it's touching a bracket, you have to multiply whatever's inside the brackets that many times. Now it also says down here a calculator can be used to evaluate a power such as negative 7 to the 5th power. And I've already told you that. You can use your calculator. So this one just equals negative 7, and then it's got to go 5 times. This is, you know, there's a lot of multiplication, and your numbers are getting pretty high when you're multiplying the same thing together 5 times. So, you know, if I look at my calculator, I'm gonna you know, crank it out on my calculator, but I can probably help myself and reduce the number of mistakes I make if I count the number of negative signs. Okay? Because if there's an odd number of negative signs, the answer is going to be negative. If there's an even number, okay, of negative signs, it's going to be positive. So if I look at this question right here, I'm going to say, well, there's 5 negatives. So my answer is going to be negative. So I might as well just put the negative sign right there. And now that I know it's negative, I can just do 7 times 7 times 7 times 7 times 7. So that's 5 times. And the answer is 1,600. Sorry, not that. 16,807. And I probably shouldn't have written 8. Sorry, did I say 807? I did 807. Maybe I'll just erase that to make it a little bit more clear. That's supposed to be a 0. All right. Okay, so I took care of the negative first just because I knew, because there's an uneven number of these, there's an odd number of negative signs. I knew the answer was going to be negative. So I just put down the negative before I even started figuring out what 7 times 7 times 7 is, just to make sure I didn't make any mistakes on my calculator. Okay. Now, writing down the steps that your calculator uses, well, actually we did that already. Okay, we just did this. That's basically all I did on my calculator. Okay. Again, if your calculator has a button where you can do exponents, you're welcome to use that. Every calculator looks different when you're looking at exponents. Sometimes it'll look like, it'll look like n to the power of x on your calculator. Sometimes it uses that sign on your calculator. Okay, it's like I say, every calculator is gonna look different. So I can't really tell you what yours looks like, but those are the two sort of normal ones. Okay, or you can just multiply the number as many times as you need to manually, like I did up here with negative 7 times negative 7 times negative 7 times negative 7. While I'm here, okay, just make sure I didn't miss any questions here. That's a very, very short little section there, so I'm going to do 2 in one video. So the powers of 10 and the 0 exponent, also a very important concept. This is 2.2, so this is actually the second section of Unit 2. Okay. Powers of 10 are very easy because all you do is put a 1 and then put the number of zeros, make sure the number of zeros matches the exponent. So in this case, 10 to the power of 9, we don't need to punch that into our calculator. We can actually figure it out very easily. We just write 1, and then we need to write 9 zeros. So it's 1, 2, 3 zeros, 4, 5, 6, 7, 8, 9. Okay, so that's really easy to do powers of 10. And if we look at their answer, it should be the same thing. 3, okay, 6, 9 zeros. The same thing all the way down. Let's go all the way down to 4. It's just 10 with 4 zeros. 10 squared is just a 1 with 4 zeros. 10 squared is just a 1 with 2 zeros. When we get down to 10 to the power of 1, well, it's the same thing. It's a 1 with 1 zero. This is the new one here. Okay? The 0 exponent. The 0 exponent is always equal to 1, no matter what number it is. And the reason for that is basically when we do, it'll make a lot more sense when we do division of powers, and you're going to see how we figure out what this exponent is for certain questions, and hopefully it makes a lot more sense. Okay, so we can make a similar table for any integer base except 0. Okay, 0 to the power of anything is just 0. It never matters in mathematics, so we're going to skip 0. But any other number we can make one of these charts for. We can make one for, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, etc. For any number other than 10, it gets a little bit more difficult after you get to the power of 3, power 4, power 5. That gets more difficult, so feel free to use your calculator. But 10s are easy, and 1s are easy because 1 to the power of anything is always 1. Because if you think about it, let's just say 1, I'll just do this over here. Okay, let's just say 1 to the power of 3. Well, that's really just 1 times 1 times 1, which is 1, right? So it doesn't matter what this power is. 1 to the power of anything is just going to be 1. The only thing you got to watch out for is if there's a negative sign or not. Okay, so 1 equals 2 to the power of 0. There, it's 1. 1, 13 to the power of 0, it's 1. Negative 5 to the power of 0, it's 1. So it's always 1. The only thing you got to watch out for is those brackets. Okay? So there's the zero exponent law. A power with an integer base other than 0 and an exponent of 0 is equal to 1. So any power, so any one of these with an integer base, 2 is an integer, okay, 13 is an integer, negative 5 is an integer, other than 0, well, these numbers clearly aren't 0, and the exponent is 0, the exponent clearly is 0, is always equal to 1. So that makes it kind of handy, right? If you see anything to the power of 0, you know it's probably going to be equal to 1 or negative 1. Okay, let's evaluate each expression. 4 to the power of 0. Well, we know that's just 1. Negative 4 to the power of 0. Now this one's a little different, okay? We got a negative sign and we don't have any brackets. So the 0 is only applied to the 4, which means we've still got that negative sign hanging out front, and 4 to the power of 0 is 1. So that one's actually negative 1. So that's the one you got to watch out for. Yeah, I'm just going to say watch out for these. The brackets make all the difference in the world, and that's what this one's going to illustrate. The 0 power is applied, it's touching the bracket, so everything in the brackets the power applies to. And, well, we know that anything inside brackets, anything to the power of 0 is 1, so that one's just 1. So that's where you got to watch out for the difference between those two. Okay, now, write 3,452 using powers of 10. So, typically what we call this is something called expanded form, and you have probably seen something similar to this in mathematics when you're figuring out numbers for the very first time in grade 2, I think it's grade 2, grade 3, where you start looking at numbers and the places. So if you looked at the number 343, there's 3 1s, and there's 4 10s, and then there's 3 hundreds, right? So this is very similar to that. Very similar to that. So let's just look at the way you would have done it before. Okay, so you would have written it before as 3,000s. Okay, hopefully this isn't new. Like I said, this is kind of way back to grade 2, grade 3. 400s. Okay, 5 10s, and 2 1s. But when we're writing this using powers, we actually have to go one more step. Okay, so what we're going to do is we're going to do, I usually just start at the big number, okay? So 1,000, okay, 100, 10, and 1. We have to find out what this is to the power of 10. Well, we know that's easy because you just count the zeros. So this is 10 to the power of 1, 2, 3. Easy. Okay, this is 10 to the power of 1, 2. And I think you can see a pattern. This is just 10 to the power of 1, okay? And this is 10 to the power of 0. Remember, anything to the power of 0 is 1. Now, you don't have to show all of these steps when you do these questions. I'm just trying to make sure you understand how we get from where you wrote these numbers in grade 2 to now using powers of 10, and then we'll get the final answer up here. So the final answer up here is actually 3 times 10 to the power of 3. Okay, so 3,000 would be 3 times 1,000. So 3 times 10 to the power of 3. Okay, then plus, what's the next one? Okay, it's 4, and we're going all the way back here to the 4, right? These are the numbers that we really care about. 4 times 10 to the power of 2, okay, times 5 times, sorry, that's plus. Plus 5 to the times 10 to the power of 1, and then I got one more in here. I'm not going to have much room here. 1. Okay, plus 2 times 10 to the power of 0. So the final answer for all of this, I'll just write it in slightly neater fashion. 3 times 10 to the power of 3 plus 4 times 10 to the power of 2 plus 5 times 10 to the power of 1 plus 2 times 10 to the power of 0. So if we look at this, this is the final answer, but let's just deconstruct it to make sure you understand why this is the same as that. Okay, 3 times 10 to the power of 3, so that's 3 times 1,000. That's 3,000. Okay, 4 to the power, or 4 times 10 to the power of 2, that's 4 times 100 is 400. Okay, 5 times 10 to the power of 1, that's just 5 times 10, that's the 50. And then 2 times 10 to the power of 0, well, 10 to the power of 0 is 1, so 2 times 1 is 2. So basically we took this number and we deconstructed it. Okay, we deconstructed it, and it looks like this in an expanded power form. It says, use powers of 10 to write each number in the above paragraph. I'm not going to read the whole paragraph. I'm trusting you can do that on your own. The first number is 600 hectares. And we don't really care about the hectares. Let's just write the number, right? So 600, if we write that as power of 10, well, it's always going to be 6 times 10 to the power of, well, how many zeros? 2. Okay, so that one was nice and easy. 6 times 10 to the power of 2 equals 600. What's the next one here? 5,700 years. Okay, so the next one is 5700. Okay, we've got an extra. We only had one integer in this one. We've got 2 here that we got to deal with. So let's start with the 5. I always start with the far end. 5 times 10 to the power of. Now, this one, you have to look at all of the numbers behind the 5. Okay? So you have to sort of pretend this 7's a 0 for now. So there's 1, 2, 3 zeros. So that's 5 times 10 to the power of 3. Basically, 5 times 1,000 is 5,000. That's how we get the 5,000 part. Plus 7 times 10. It's always times 10, right? Okay? 7. How many zeros are behind the 7? Or how many numbers are behind the 7? 2. Okay? So it's 7 times 10 to the power of 2. Okay? And then there's nothing else after that. Just 0, so we don't have to go any further. So this is 5,000. Okay? And then obviously there's the plus sign. And then this is 700. So you can see it pretty obviously now that this part plus this part equals that part. Okay, next number is 10,000. All right? 10, 1, 2, 3. This one's nice and easy because it's just got a 1 and a bunch of zeros. So we can just write 10. You could write 1 plus 10, but or 1 times 10, but really, like, when you're doing 1 times something, it doesn't bother. You don't bother to write it down. So we just got to count the zeros. 1, 2, 3, 4 zeros. Okay, so that would be 10 to the power of 4. If you were to try it on your calculator, you would find out 10,000 is indeed 10 to the power of 4. And I think we got one more number here. Oh, we got a couple more, actually. Estimated close to 60 million. That one was written out in word form. See? 60 million. Okay, what's 60 million? 60. 1, 2, 3. That would be 60,000. 1, 2, 3. That'd be 60 million. So this is 6 times 10 to the power of, well, it's all zeros after that, so that's great. 1, 2, 3, 4, 5, 6, 7. That would be 6 times 10 to the power of 7. All right? Less than 100 years later, there they are. They're doing words again here. 100 is just 10 to the power of 2. We know that 100 is 10 squared. We know that. And now fewer than 1,000 animals remain. 1,000's easy as well. Okay, 1, 2, 3 zeros. I'll put those 2 there to show that. There you go. So writing as powers of 10 is, once you understand how to do it, it's pretty uncomplicated, really. It's just splitting a number apart, and as long as you follow the process and understand that the addition part is how you kind of combine the number back together, shouldn't be too much problem there. I don't think I'm going to go into orders of operations with powers in this video. That should be the next video. So what I'd recommend is that you attempt the questions for 2.1, 2.2. The chapter textbook is up on the website. Sorry, the textbook's chapter 2 is up on the website. And the answer key from the back of the book is there too. So I want you to go through the workbook, make sure you've completed your notes in there, and then look at the textbook questions that I've requested you do from the website, and make sure your answers match, and feel free to email us if you've got any questions. Have a good day.